Good morning. Today we are going to discuss about design thinking based video. So in that design thinking, it involves 5 stages. That is called as empathy, define, ideate, prototype and testing. So in that empathy part, we will give the solutions for the one problem. So in that solutions, many solutions it will be applicable for single problem. That is called as empathy. Next one is define. So what are all the solutions it will be implemented to this problem. And next one is ideate. How we are implementing this problem. And next one is prototype. So in that solutions it will be suitable or not. These are all the things it will be evaluated by a prototype and testing. So today we are going to take DT based topic like cryogenic engines. So in that cryogenic engines, it is one type of air breathing engines. It have a liquid propellant and it will run lower temperature. So next I hand over the sessions to students. The students will elaborately discuss about each stages of DT.
Today we are talking about empathy for cryogenic engines. Empathy, what's the need? For example, why do rockets need such powerful engines? How we can make spaceful travel cheaper, safer and go further? For rockets, need huge power to escape Earth. Fuel gets super hot, but cryogenic engines use super cold like liquid hydrogen and oxygen to give powerful push.
So for the define part, what's the real problem? How might we build a rocket that can handle high pressure and high temperature, also handle in a very colder conditions, like by providing its maximum power in super cold, by using super cold fuel and giving its maximum power without breaking or overheating. That's the challenge with cryogenic engines. They are super cool literally, but super hard to build. So for the idea part, we've come up with so many ideas. Let's ask questions. Should we store the fuel tanks in a special vacuum tanks? Like instead of normal fuel tanks, why don't we use special vacuum tanks that can handle these very colder fuel? Or can we make parts that work in minus 250 degrees Celsius, like literally whichever the fuel touches or travels in parts that can be made in, to handle those minus 250 degrees Celsius colder conditions. What about 3D printed parts that we can make which can handle this colder condition also without breaking or overpressuring? Can we make this lighter or stronger? That is the whole idea. Like their engine exists, but it is not that can handle that much of a cold condition and overheating pressure. Also, it has to be lighter and stronger. So we dumped all our ideas by keeping in mind that any idea is not that too much out of this world.
Prototype part of the cryogenic testing engines, we are making small models of the fuel tanks and then tiny versions of the turboprop pumps, and heat maps are to help where the cold streams are passing through the engines. This type of the demos we are really helpful for to developing the cryogenics engines. Of the prototype making, we are used to analyze where the cold streams are passing through the turbo engines. We identify the turbo engines where it passes through the cold fuels and the cold flows are passing through engines at minus 250 degree, which it stands for to the longer and larger distance to carry out the fuels and to carry the machines on the space.
Yes, this cryogenic engines handle the extra cooked and electricity give increase the thrust to separate under pressure. Each test as far backs and gets closer to real cryogenic engine. Just example for ISL C20 is the upper stage cryogenic engine. GSLV third stage launch vehicle used for India ISL.